Okay, so that is a polyhedron. The two types of polyhedrons we're focusing on are prisms and pyramids. To me, pyramids is easy because I always think of like the Egyptian pyramids. It looks like this. And then prisms have two parallel and congruent polygon bases. So here in the picture, this top right here would be a base, and then the bottom right here is a base. And by definition, those bases are the same dimension. So if you find the area of one, you have the area of the other one. And then to name a prism, you use the shape of the base to name it. So in this case, this would be a pentagonal prism. And then over here, so it wants us to name these, this has a triangle base, even though it's kind of sideways. This would be a triangular prism. Zoom in here too. This right here, it looks like a cube, but I'm also going to call it a rectangular prism. Rectangular prism or cube. We don't know the specific dimensions, so we don't know exactly, but the rectangular prism or cube. Then this one has a hexagonal base, so this would be a hexagonal prism. And then this one, a pentagon base, so pentagonal prism. Okay, and then the second type of polyhedron is a pyramid. One polygon is the base, like the bottom, and then the lateral sides are triangles for a pyramid. So here, this top point is called a vertex, and then this right here is the base, and we use that base to classify it. So here we look at the shape of the base. It looks like 1, 2, 3, 4, 5, 6 sides for the base, so that would be a hexagonal pyramid. Then this has a rectangular base, so this would be a rectangular pyramid. Then this has a pentagon base, so pentagonal pyramid. And this one, a triangular base, would be a triangular pyramid. Okay. Next. Ready for the next page? Too fast, too slow? You got it, Genesis? You good? Okay. Then 3 more 3D shapes. Cylinder, cone, and sphere. These are not polyhedrons because they do have curved edges. A cylinder has 2 bases, and the bases are circles. So this is the base, and this is the base. And then a cone, this top point is called the vertex, and then this circle down here is the base. And then for a sphere, it looks like this. So for the cylinder, I mentioned this is bases are 2 parallel and congruent circles. Forgot to fill that in. Side is 1 smooth surface. Got it. This was put in the wrong place. And then a sphere, the definition of a sphere, this does come up on testing sometimes, is a set of points that are the same distance from a given point called the center. So definition of a sphere, generally the formal definition is all the points equidistant from the center makes a sphere. Okay, next, then we're going to do some calculations. Says surface area and volume, but we're just going to focus on one of these at this time. We're going to just focus on volume of prisms, cylinders, pyramids, etc. So to find the volume of any prism, you find the area of the base and multiply by the height of the prism. We are going to use the equation for this. The reference sheet, I'm going to switch over to the reference sheet for FSA right here, or EOC, whatever it's called these days. For a prism, so prism and cylinder, the volume is this, capital B times H. That capital B stands for area of the base. So we're going to find volume, and V equals capital B times H, and B is area of the base. So we learned with prisms that prisms can have different shapes as the base, so depending on that shape, this area of the base might change, or like the formula for it will change. Okay, so here we have a cube. Let's say that we are told that this dimension right here is 4. So we have a cube, and this dimension is 4. With a cube, all the sides are the same, they're squares. So if this is 4, then this is 4, and this is 4. And to find the volume, we have to find the area of the base, which in this case is a square. So we do 4 times 4 times the height, which is 4. And then you'd solve. 16 times 4, and that comes out to 64 units cubed. Volume, you use units cubed, or like centimeters cubed or whatever. So that is finding the space inside of that cube. If you're more of a conceptual person, let's say we have a rectangular prism, to find the volume of this, you'd find the area of the base and multiply it by the height. So you know those like community events where they have you like guess how many candies are in a container? You could actually use the equation for volume to like hack it and get a pretty close guess. So if you counted all the candies on the bottom of the container and then counted the number of layers of candies and multiply those two numbers, you'd have how many candies are in the container. Now most candies aren't like perfect cubes like we use with volume, but you could get a pretty close guesstimate. Or if you even wanted to hack it even further, instead of like being really suspicious and counting all the ones on the bottom, you could actually count the width and the length, how many candies are the width and the length, multiply those two numbers to find out how many are on the base, and then count the layers and then multiply those and get the volume, or how many candies are in here. So that is exactly what we're doing with volume. So we find the volume of this. We're essentially finding how many candies are on the base of this rectangular prism. So we're finding volume equals, I'm going to draw a line here, area of the base times the height. So for this rectangular prism, the dimensions are going to be 4 by 6 by 3. So to find how many candies are on the bottom, we do 4 times 6, and then times the height is 3, and we calculate it. We get volume equals 72 units cubed. Okay. For the next one, we also have a prism. The difference here, though, is the base is now a triangle. So we're still going to use the equation volume equals area of the base times the height, but with the base being a triangle, we have to use a different equation than just length times width. So the equation for area of a triangle is 1/2 base times height of the triangle, and then we'll multiply by the height of the prism. So the dimensions we're going to use, 5, 4, and 3. So volume equals 1/2. The base of the triangle is 4. The height is 5. And then the height of this prism is 3. Okay. Because we're dealing with all multiplication, we can multiply these numbers in any order, so it kind of depends on what you're comfortable with. 4 times 5 is 20. You already got it, Alex. Good job. Okay, and then 1/2 times 20, or half of 20, or you could think of it as 20 divided by 2 would be 10 times 3. And yes, we could have plugged this in a calculator, but with simple math, I'd almost rather rely on my brain, because when I punch stuff in, I could make errors there. We get 30 units cubed. Okay, next, ready, set, okay. Cylinder, surface area and volume of cylinder. Again, we're just going to focus on volume right now. Volume of the cylinder, you find the area of the base again, and multiply by the height. So if this cylinder was filled with candies, and we're trying to guess how many were in there, we count how many are on the bottom, and then multiply by the number of layers. So that is exactly what we're doing. To find the area of a circle, we're going to need to use an equation for that, but the radius we'll use is 3, and then the height we'll use is 10. So for volume of a cylinder, when you look on the reference sheet, cylinder right here, volume equals, again, capital B times H. So volume equals area of the base times the height. Area of the base is a circle, so area of a circle, which we went over yesterday, area equals pi r squared. So volume equals pi r squared for area of the circle times the height. Okay, now we plug in the numbers. Three squared would be 9. Okay, so what I did here was I solved this in terms of pi. A lot of time on standardized testing, they'll ask you to solve in terms of pi, and what that means is it just doesn't want you to do the last step and multiply by the pi binder, 3.14. This is actually the most accurate answer, because anything else after this we're going to be rounding pi, but sometimes they ask you in terms of pi, it would be 90 pi. If all the answers are in decimals, then what you have to do is, in the calculator, just do 90 times pi, and you get the answer, and then you'll have to round it to whatever decimal places they want you to. In this case, we'll just do 2 decimal places, units cubed. So both of these are correct answers. It just depends on what's in the multiple choice or how they're asking for the answer. Okay, next, volume of a pyramid. To find the volume of a pyramid, you find the area of the base and multiply by the height, but then we divide by 3. So I'm going to use a pencil to kind of show this. With the prism, we did like length times width of the base and then multiplied by the height, and that gave us this total area of the prism. Well, a pyramid is 1/3 of that space, so we're doing the same calculation, it's just at the end we're dividing by 3. So for volume of a pyramid, and it says right here, pyramid volume equals 1/3 capital B times H. So volume equals 1/3 capital B times H. And again, this capital B is area of the base. So you actually have to calculate something to get that part. And the dimensions of this we're going to use is 5 by 5. And then we'll say the height is 6. So 1/3 area of the base here would be 5 times 5, and the height is 6. Here's where people get stuck sometimes, like how do I put this in a calculator? There's different ways to do it, but 1/3 times anything is the same as dividing by 3. So 150 divided by 3 would be 50 units cubed. And I'll do it that way. There's no pi in this answer because we aren't dealing with a circle. Okay, next page. Okay, a cone. Volume of a cone. Just like with the prism where we divided by 3, a cone would be 1/3 of an entire cylinder. So we essentially find the volume of a cylinder and then divide by 3 for this one too. So volume of a cone, you find the area of the base, multiply by the height, and then divide by 3. So volume of a cone, volume equals 1/3 area of the base times the height. And the dimensions that we're going to use are 3 and 5. Okay, so for the area of the base, we're dealing with a circle. So the area of a circle would be pi r squared times h. And then we plug in our values. And we're going to solve. On some of the homework problems, they do give you diameter all the way across that circle. So you might have to divide that diameter by 2 to get the radius to plug it into the equation, just so you know. And then, once we got this far, we'll just keep solving. Okay, once we get here, we can multiply these numbers in any order. So I'm going to do 1/3 of 45 to get 15. So here I get volume equals 15 pi units cubed. So if they asked for the answer in terms of pi, this would be my answer. If the answers were in decimals, I just take it one more step and do 15 times pi equals 47.12. Okay, last but not least, a sphere. People actually find this the easiest because you don't have to plug in one equation into the other. It is what it is. On the reference sheet, if you look for sphere, the volume is right here, 4/3 pi r cubed. So volume of a sphere, volume equals 4/3 pi r cubed. And the radius we're going to use is 4. So we're going to plug this in. Volume equals 4/3 pi 4 cubed. Four cubed comes out to 64. This is where some people get stuck, like how do I put 4/3 in a calculator? I'm sure there's different ways. But what I find the easiest is I do 4 divided by 3 for the fraction to get the decimal, and then I'll multiply by 64, and we get 25.33. Volume equals, or 85.33. I'll leave it in terms of pi here, units cubed. Or if they want it not in terms of pi, times pi equals 268.08. And that's it. Okay, thank you. And that's it for the chapter. If you want to, we're going to do the homework on Schoology. I will enable that for you in a second. You can turn in your note packets when you're ready, and I'll just grade them and give them right back to you. If you finish that, work on Alex. And yeah, if you have questions, please let me know on those on the homework questions.